Hey everybody, this is Mr. Ainsworth, and we're going to get into Chapter 2, Section 1 and talk about properties of exponents. And we're going to explore quite a few rules here, probably about 5 of them. So for each one, what we want to do is explore with some real numbers because it's easier to understand with real numbers versus variables. And then we will state the rule after we look at some patterns here. Okay, the first rule is called the product rule. And before I state it, like I said, we want to take a look at some real numbers, some real cases here, and look at some patterns, and then I'll generalize it. All right, so let's take a look at multiplying variables with the same base. All right, so let's take a look at this. 2 to the second power times 2 to the, let's say, third power. When you're working with these, what you want to do is understand what 2 squared means and 2 cubed means. All right, and the way we handle it is this. 2 squared, all right, means 2 times 2. The exponent tells you how many times you multiply the base by itself. And the 2 to the third power, or what we say is 2 cubed, means we're taking 2 times 2 times 2. We're multiplying 3 2's together. So 2 times 2 times 2. All right, so in other words, 2 squared here becomes 2 times 2. 2 cubed becomes 2 times 2 times 2. That's called expanding the numbers here. All right, and we want to evaluate what that is. Not as a total number here, but we want to take a look at it in terms of exponential form. When you multiply 5 2's together here, another way to write that is 2 to the 5th power. 2 to the 5th power means you're multiplying 5 2's. So the question is, when you multiply variables with the same base, what do you do to the exponents? All right, so you take a look at the 2 here and the 3 here, all right, and the 5. What do you do to 2 and 3 to get the 5? What do you do? All right, I want you to think about that. I'll tell you in a minute. Well, I mean, do you add them? Do you subtract them? Let's just go for it here. What do you do to their exponents when you're multiplying numbers of the same base? Well, you can't multiply them because 2 times 3 equals 6 and not 5, so that doesn't work. But 2 plus 3 equals 5. And so what you can do is you can add the 2 and the 3 to get to the 5. In other words, you can add the exponents together when multiplying numbers of the same base. So when multiplying, all right, numbers with the same base. Underline the word same, okay? Same base. You're going to add those exponents. All right, does that always work? So let's take a look at it one more time before we state it. Suppose we have a 3 to the third power times 3 to the fourth power. Okay, and let's take a look at what that is. Well, 3 to the third means you're multiplying 3 3's together. 1, 2, and 3. So 3 to the third becomes this right here. 3 to the fourth means that you're multiplying 4 3's together. So times 3 times 3 times 3 times 3. All right, so 3 to the fourth becomes the product of these 3's together here, 4 of them total. Well, how can you represent that? Well, you're multiplying how many 3's together here? 1, 2, 3, 4, 5, 6, 7. So this can be written as 3 to the 7th power. Because that's what 3 to the 7th power means. You're multiplying 7 3's together. So the question is, how do you handle the exponents to get 7? Do you multiply the exponents or do you add? Well, 3 times 4 is 12 and not 7, so you can't multiply them. But we know that 3 plus 4 equals 7. All right, we can say that it's going to be 3 to the 3 plus 4 power, and that will give us 3 to the 7th. So once again, you're going to be adding the exponents when they have the same base. And that's rule number 1. And we can generalize it like this. And let's put this in red. Okay, this is called the product rule. We can say that x to the n power times x to the m power equals x to the n plus m power. Okay? When multiplying numbers of the same base, you add their exponents. Okay, so from here to here, we add, okay, exponents. When multiplying numbers of the same base, we add their exponents. Or you can say add exponents when multiplying numbers of the same base. It really doesn't matter how you state it. So this is the general rule, and it's called the product rule because product means multiply. You're multiplying numbers of the same base. So when you handle something like this right here in example 1, x cubed times x to the 9th, you're going to take your exponents and you're going to add them. You're going to take x to the power of 3 plus 9, which is x to the 12th power. And I want you guys to remember something. I want you to step it out. Okay? And you're probably wondering why, Mr. Ainsworth, because, you know, I can do this in my head. Well, believe it or not, stepping it out forces you to have good habits and teaches you that when you're multiplying numbers of the same base here, which is both x here, you're going to be adding these exponents right here. It actually reinforces what I'm saying. Add exponents. All right, so step it out, write it out, make this two-step process here. On the next one, we have y to the 5th times y squared. So that becomes y to the 5 plus 2 power, all right, which is y to the 7th. So y to the 7th power. Again, step it out. It forces you to have really, really good habits. And if you can write it correctly, then you really know the rule. And that's why I'm really specific and I have you do that. Okay? If you can't write it correctly and step it out, then you really don't understand what's going on. So it really forces your brain to think correctly and do it correctly here. All right? The next rule is called power to a power. Let me highlight these here. So the first rule is called the product rule. The second one is called the power to a power. Let's see what this is all about. What is a power raised to another power? About. So let's take 2 to the second power raised to the third power. This is a power raised to another power. Hence, power to a power. Okay, so what is this equal to? Well, I know that when you cube something, you multiply it by itself 3 times. So this is going to be equal to 2 squared times 2 squared times 2 squared. Okay, so we have 2 squared times 2 squared times 2 squared, and notice that we're multiplying variables of the same base. So knowing what we know above, well, we know that when you multiply variables of the same base, you add their exponents. So let's add these 2's right here. Well, that gives us 2 to the 2 plus 2 plus 2. What does that equal? It equals 2 to the 6, because 2 plus 2 plus 2 equals 6. So the question is, how do you get from here all the way to here? All right, do you take the 2 powers and do you add them to get 6, or do you multiply them to get 6? And what's the obvious answer here, guys? All right, 2 plus 3 is 5, which doesn't give us our result. But 2 times 3 is 6, which does. So what you want to do here is when you take a power to a power, you want to multiply the exponents. When you have a power to a power, you want to multiply the exponents. Multiply the exponents together. All right? And so I'm going to say it like this. Power to a power, multiply exponents. That's what you got to remember. Okay, that's our power to a power rule. That's what we call it, power to a power. Ways to take a power, raise it to another power. We multiply those exponents. Simple. Okay? Now, so in general, this is how it's stated. It states that x to the n power raised to the m power equals x to the n times m power. Notice how I multiplied the 2 numbers here, the 2 variables. All right, you multiply the exponents together. That's how you see it in variable form. But let's go ahead and apply it. Okay? We have y to the 5th times, to the third power. Y to the 5th raised to the third. And that gives us y to the 5 times 3, because again, you want to multiply the exponents here. Multiply exponents. And you get y to the 15th. Again, I'm stepping it out here, guys. And you should do the same. Why? Because it forces your brain to think correctly. And once again, if you can write it correctly, then you're thinking correctly. If you can't write the steps, then you don't fully understand what you're doing. So step it out. Here we have y to the 4th raised to the 6th. That's y to the 4 times 6 power, and that's y to the 24th power. 24th. Okay. Make sure I write the right number there. Okay? So step it out. Simple. Okay, the next one here we have what's called a a product to a power. That's our next thing we need to explore. And a product looks like this. It looks like x times y, something times something else. So let's take a product like this, multiply two things together, and raise it to a power. So let's take, let's say let's take 2x cubed, and let's raise it to the third power and see what happens. Okay, so what we're going to do is we're going to cube this thing, and when you cube something, you multiply it by itself 3 times. So we're going to take 2x cubed, multiply it by itself 3 times. That's what cubing means. Alright, so I cubed it right there. Now I'm going to rearrange things. Order in the multiplication does not matter, and regrouping does not matter in multiplication either. So I'm going to group up the 2's, and I see 3 of them. And then I'm going to group up the x's. I see x cubed times x cubed times x cubed. So I regroup. From here to here, I regroup. Alright, the reason why is because now you can see something. 2 times 2 times 2 is 2 cubed. And then x cubed times x cubed times x cubed is x to the 9th power, because you're going to add the exponents here. So when you compare the first expression with the end expression, what's going on here? Notice that the factors in here, these are called factors. The factors in here are both raised to the 3rd power. 2 is being raised to the 3rd power right here. And then x cubed is raised to the 3rd power. And as I talked about above, when you go power to a power, like x cubed cubed, you multiply the 3's together to get 9. So you raise each factor to the power. So in general, it looks like this. X times y raised to the nth power equals x to the nth power times y to the nth power. You raise each factor. Okay, each factor. Okay, again, x and y are called factors. Alright, raise each factor to the power. That's what you want to do. Alright, so remember that. Whoa, hang on here. Okay, sorry about that. So you raise each factor to the power. So let's go ahead and apply this. And again, step it out. I keep saying that because every time you get in a good habit of doing this, you're going to have a whole lot more success. Trust me on that. I've been teaching for over 21 years, and I've seen a lot. And trust me, if you step it out, you have a lot more success. Okay, 3y to the 4th raised to the 2nd power means we've got to take 3y to the 4th and multiply it by itself. So you take 3y to the 4th, multiply it by itself, 3y to the 4th. That's what squaring means. Okay, and now you rearrange. Okay, regroup. 3 times 3. Well, you know what? I take that back. What we're going to do is a different way. We're not going to expand it. We're going to do it the fast way. So sorry about that. We'll do it the fast way here. We're going to take each factor to the power. So we're going to take the first factor here, which is the 3, and square it. Okay, again, we're going to raise it to that 2nd power. So I'm going to take 3 squared, all right, times, and then I'm going to take the y to the 4th, the other factor right here. Again, these are called factors. All right, the y to the 4th, and I'm going to square that. So the first thing you do is you take each factor, the 3 and the y to the 4th, and you square them both. Then you simplify. 3 squared is 9. And then y to the 4th squared, or raised to the 2nd power, is a power to a power, and you multiply those exponents. So you get y to the 8th. And you write it as 9y to the 8th. And you step it out. On the second one here, you have, you're going to take both factors. Okay, and there's 2 factors in here, 2, and then you got w cubed. These are called factors. And you're going to raise each to the 4th power. So let's do that. You're going to take 2 to the 4th times, okay, I'll use parentheses instead, w cubed to the 4th. Notice how I raise each factor to the 4th power. And then you simplify. 2 to the 4th is 2 times 2 times 2 times 2. And that's 4 times 4. 16. So this is 16 here. Times w to the 3rd raised to the 4th. Alright, and that's going to be w to the 12th because the power to the power you multiply. And you're done. All right, one more time. You're going to take each factor. There are 3 of them. Factor is 5, and then p squared, and then x to the 5th. Again, these are called factors. And you're going to raise them all to the 3rd power. So 5 to the 3rd times p squared to the 3rd times x to the 5th to the 3rd. And now you're going to simplify it. 5 to the 3rd is 5 times 5 times 5. That's 25 times 5, which is 125. So this is 125 here. Notice how you do my side work here. Show your side work unless you can do it in your head. And then power to power you multiply. So you're going to have p to the 6th here times x to the 15th. 5 times 3 is 15. 2 times 3 is 6. Alright, and that's all there is to it. Alright, now there's a couple more rules. So let's explore the quotient rule. Alright, dividing variables of the same base. Remember, a quotient means fraction. It means division. Alright, so let's take a look at that. Let's take a look at x to the 4th divided by x squared. Alright, and the very first thing we do to understand something like this is expand. So you expand each, expand and simplify. Alright, you want to do that first. Alright, so let's do that. We got x to the 4th is x times x times x times x. That's what that means. X squared is x times x. So the question is, what does all this mean? Well, let's understand something here. So we know that x divided by x is like 2 divided by 2, or 5 divided by 5, or 6 divided by 6. Alright, it's 1. Alright, so this is 1, and that's 1. And notice what you get, x times x, which is x squared. So the question is, how do you use your exponents here to achieve your result? What do you do to these exponents? Do you add them, subtract them, multiply them, divide them? I mean, what do you do? And so if you add them, you get 6. Okay, so that obviously doesn't work. Multiply them, you get 8. That doesn't work. But if you subtract them, ooh, that works. So another way to get it is take x, which is your base, take the top exponent, subtract the bottom exponents. Okay, you take your 4 minus 2, and that will give you x squared. And notice that's the same. So what you want to do is when you divide like bases, when you're dividing now, you're going to subtract the exponents. So let's write that down. So when dividing, like bases, subtract the exponents. Subtract the exponents. And as a rule, it looks like this. If you take x to the n divided by x to the m, that's going to be equal to the x to the power of n minus m. Notice how I subtracted the exponents right here. Alright, let's apply that. And remember, here we go again. We're going to step it out. We are going to show the steps no matter how simple they are. Alright, so here we go. We're going to take x to the 12th divided by x squared. So that's going to give me x to the 12 minus 2, which is x to the 10th. Notice how I step it out right there. I show the two-step process. On this one here, you get 14y to the 6th divided by 7 y to the 4th. You handle the fraction first. 14 divided by 7, that's 2. Okay? Right there. Times y to the 6 minus 4. You got to subtract the exponents. And that will give you 2y squared. Because 6 minus 4, that's obviously 2. Alright, now this is a video, so remember that. And you can go ahead and pause and replay and rewind and do whatever you need to get the rules down, okay? And hear it once or twice or 3 times, because you can pause and play and rewind anytime you want. If I go too fast for you, rewind and hear it again and see it again until you get it. Okay, the last rule is a quotient to a power. So I need to take a fraction like a divided by b and raise it to a power. So let's do that. Let's take 3 divided by x squared, and let's raise it to the power. Let's take it to the third power. What the heck? Okay, and then when you cube something, you multiply by itself 3 times. So 3 divided by x squared times 3 divided by x squared times 3 divided by x squared. That's what cubing means. This is called cubing. And you want to see what you get. Well, we know when we multiply fractions, you multiply the numerators. Multiply all these and state it. Alright, so we get 3 times 3 times 3 can be written as 3 cubed. And then you multiply the denominators. That's how you multiply fractions. So you get x squared times x squared times x squared, and that's x to the 6th power, because 2 plus 2 plus 2 is 6. When you multiply like variables, you add their exponents. So then the question is, how do you get these answers? How do you get from here all the way to here? What do you do to the 3? So notice, all right, 3 is being cubed. Notice that x squared is being cubed. All right, x squared to the 3rd power, it gives you x to the 6th. So what you want to do is, for each of the factors here, you want to raise them to the power. You raise both the numerator and the denominator to the power, and that's the key. All right, you raise, all right, both numerator, oh, that's not how you spell both, numerator, all right, and denominator, all right, to the power. In other words, if you take a fraction like x divided by y and you raise it to the power of n, x is in the numerator and y is in the denominator. You're going to take x and raise it to the nth power, and then you're going to take y and raise it to the nth power. You're going to raise them both. That's all you have to do. And if you step it out, it's pretty easy. All right, so here we go. We're going to take the numerator 2 and raise it to the 3rd power. Then we're going to take x cubed and raise it to the 3rd power. And then we're going to simplify what we get. 2 cubed is 2 times 2 times 2, and that's 4 times 2, or 8. So the numerator is 8. We have a power to a power here, so you multiply the exponent, so you get x to the 9th. Okay? Let's try it again. We're going to take every single factor and raise it to the 3rd power. The 3 to the 3rd, the y to the 3rd, the 4 to the 3rd, the x squared to the 3rd. Okay, and we're going to step it out. So here we go. The numerator first. 3 to the 3rd times y to the 3rd. You're going to raise each factor to the power. You're going to raise each factor to the power. In this case, the power of 3, okay? Divided by 4 to the 3rd times x squared to the 3rd. And then you're going to simplify it. Raise each factor to the power, and then simplify the result. Okay? So here we go. 3 cubed is 3 times 3 times 3. That's 9 times 3, or 27. So from here to here, we got 27 times y cubed, which can't be simplified, obviously. And then we got 4 cubed, 4 times 4 times 4, that's 16 times 4, that's 64. So from here to here, you get 64, and x squared to the 3rd gives you x to the 6th. And then you're done. The only thing you need to do here is practice like a madman. So go ahead and turn the page here and take a look at this, and do your practice on this, and check your work online, and do your best. Okay? And once again, this is a video, and because of that, you can rewind this, pause and play, listen to this as many times as it takes. Practice. Be able to try to, practice these same examples. Be able to do it on your own. All right, and give your best, and I'll see you tomorrow.